So are we okay here? Solving means what does x equal? And then a method of solving a quadratic is by factoring. All right. You must make your equation equal to 0 before you can solve a quadratic by factoring. So that's going to be the big idea of what we're working on today. We've got to make our equation set equal to 0, and then we can go about factoring and solving. So let's jump right into it. Let's get a couple of these done. So the first thing I'm going to need to do is make my equation equal to 0. My suggestion to you is to do that so that your x squared term is positive. So that's going to help you determine which side you want to move everything to. We like to keep the x squared term positive. So right now it's positive on the left side. That means I want to take this guy and I want to move him to the left side, and take this guy and move him to the left side. All right, so here's my equation. In order to move this 5x over here to over here, we would want to subtract 5x. So now I have 6x squared minus 5x is equal to -1. I also need to move that -1 over, so we're going to say +1 and +1. So now we have 6x squared minus 5x plus 1 equals 0. None of those are like terms, which is why I didn't add any of them together. Is all that part okay? Just moving the all the terms over to one side of the equation, so we have just a 0 on the other side. So then we're going to solve this by factoring. So again, factoring is the big key word. When I am factoring, what do I look for first? So now, factor. All right. So if I'm factoring, the first thing I want to look for is that GCF. Do these three terms have anything in common? So no GCF. There are 3 terms. So we're going to use the puzzle. So I'm going to fill in my little puzzle boxes here. Sorry, I'm actually going to zoom in a little so that I can write this a little better. Whoa, that was too much. Try again. All right, so remember when we're filling in the puzzle, the top box is your A times C. So that would be 6 times 1, which is 6. Your bottom box is B. B in this case is -5. So what we're looking for here is factors of 6 that have a sum of -5. So what 2 values would multiply together to give me 6, but add together to give me -5? Give everybody a second to process. So hopefully we came up with
-3.
Good, -2 and -3. All right. So now that I figured out these 2 pieces, I'm going to scoot over here so where I have a little bit more room. And I'm going to do this one by grouping. So what I figured out is that the -3 and the -2 is what we're separating the -5 into. So I'm going to rewrite my 6x squared. And then instead of rewriting -5x, I'm going to separate -5x into -3 and -2 and put an x behind each one. So -3x and then -2x. Because -3x plus -2x gives me the -5x that I was looking for. All right, the reason I'm doing that is so that I can group these so that I can get my factors. So now we're going to take and we're going to do those 2 as a group and those 2 as a group. Okay, if I get going too fast, you guys speak up, say something in the chat or slow me down. Otherwise, I'm just going to keep rolling on this one, okay? So GCF, back. Say again?
It switched back for me. I can only see your face cam.
Try to go, Jabari, try to go up to the 3 little dots on the top toolbar and see which view you have. Do you have the gallery view?
You said where? Through toolbar.
The 3 little dots up at the top on the toolbar.
Okay.
Okay, so there's device settings, meeting options. Scroll down, you should see gallery view. Make sure that one is clicked.
Okay.
Did that do it for you? Let me
Okay.
see this. I can turn this camera off.
All right, that's better. It's working now.
Does that do it? Okay,
Yes,
so
ma'am.
just because my camera was on for some reason. Okay.
Thank you.
Uh-huh. All right, so in my purple group here, I'm looking for the GCF, which in this case would be 3x. And we're dividing both of those by 3x. So we write the 3x in the front of my parentheses. And then we put the leftovers inside. So 6x squared divided by 3x is 2x. Negative 3x divided by 3x is negative 1. Okay. Now looking at my orange group, these two really don't have anything in common. So they would have a GCF of 1. But because the first term is negative, we're going to say our GCF is negative 1. So I'm dividing by a negative 1, dividing by a negative 1. So now negative 2x divided by negative 1 is 2x. 1 divided by negative 1 is negative 1. Okay, when we group, we're wanting these two to match. That's how grouping works, if it works. So they do match, so we're going to rewrite that one down, 2x minus 1. And I'm taking it out of both of those. And so what's left is 3x minus 1. And this is still set equal to 0. This little part right in here was just my grouping work to get from here down to here. Okay, are we okay to that point? Okay, so that's not any different than what we've been working on recently, just trying to factor. The only difference with this one is that we have an equal 0 right there on the end, and that's because this is an equation, not an expression. So what we've been working on before now were expressions, so there was no equal to. So now we have an equal to in there, so we have an equal 0 as we go through our work. So what you need to do now in order to solve, we have these guys factored, and what you need to do now is take each factor and separately set those factors equal to 0. So I'm going to say 2x minus 1 equals 0. And I'm going to do 3x minus 1 equals 0. And those are just two linear equations, and we should be able to solve those linear equations pretty simply. So on this one, I would add the 1 over, so 2x equals 1, divide both sides by 2, so x equals 1/2. Over here, add the 1 over, so 3x equals 1, divide both sides by 3, so x equals 1/3. So again, the directions are to solve on these, and solving means what does x equal by the time I'm done. Okay, so I'm going to zoom back out just a little bit. So there were our two solutions. So set each factor equal to 0, factor completely, and then solve for x. Okay, do I have any questions? Are we okay with that? I'm going to write in right here, now set each factor equal to 0. All right, I'm going to go ahead and give this next one a shot then. I'm going to zoom back in. So again, our directions are to solve. We're trying to solve for x. If you'll notice on this one, the 2x squared is on the right side of the equation and positive. So I think I just want to move this 18 over here instead of trying to move all this stuff over there and make my x squared negative. I don't like my x squared to be negative, okay? If my x squared is negative, it makes it harder to factor. So I say, let's keep my x squared positive, so move all the other stuff so that the x squared stays positive, or you make the x squared positive. So subtract 18 on both sides. So you have 0 equals 2x squared plus 9x minus 18. Okay, so after I set it equal to 0, my next step is to factor. My first step in factoring is finding the GCF. So what do all three of these have in common? And I see no GCF on this one. There are 3 terms again. So we're going to use our puzzle again. Okay, I'm going to put my puzzle up here. Again, the top box is A times C. So that would be 2 times negative 18 or negative 36. The bottom box is your B value, 9. That's your B. So this time I'm looking for factors of 36 that would add up to 9. But notice it's a product that's negative 36, which means that one of my values has to be negative and the other one is going to have to be positive. To get a negative product, one has to be negative and one has to be positive. So what are 2 factors of 36? One negative and one positive. When you add them up, we end up with 9. So I'm thinking that should be 12 and 3. Okay, negative 3 times 12 gives me negative 36. Negative 3 plus 12 gives me positive 9. Okay, I did the last one by grouping just because I know some of you guys like grouping. I'm going to do the next one with the box method. So both of these options are options for all of your trinomials. And it does not matter to me which one you do. I'm just trying to give you guys options for both. So I'm trying to give you, I'm trying to give examples in each scenario or in each situation. Okay, so over here, when we go through and fill in the box, the first term, 2x squared, goes in the first box. The last term, negative 18, goes in the last box. The reason we did the puzzle is for the other 2 boxes. So a negative 3 will go in this box and you need to add an x to it. A 12 will go in this box and you need to add an x to it. And now we look for the GCF on the rows and on the columns. So across this row, they have a 2x in common. Across this row, they have a negative 3 in common. On this column, an x. And on this column, a 6. Now, when you use the box, you can actually check and make sure you did the box correctly if you multiply these numbers on the outside and it gives you what's on the inside. For example, negative 3 times 6 is negative 18. So your 2 factors you've just developed or came up with were 2x minus 3 and x plus 6. Okay, that is set equal to 0. Remember, what we're doing in factoring is we're taking this and breaking it down to its 2 factors. So that's what we just got through doing here. It's still equal to 0. So now, just like we did with the last one, we're going to set each factor equal to 0 now. So I'm going to come down here and do 0 equals 2x minus 3. And 0 equals x plus 6. So each of these guys gets their own equals 0. To finish solving over here, I would add my 3 over. So 3 equals 2x. Divide both sides by 2, so 3 over 2 equals x. Over here, all I need to do is subtract my 6 over, so negative 6 equals x. Okay. So the zero product property is the property we've actually been using, which basically just says if the product of two expressions is 0, then one or both of them has to equal 0. Well, if there's a variable in there, you use that to help you solve the variable. So the zero product property is what we were just working on here. We had two things multiplied together to equal 0 together, so we made them equal to 0 separately. So that's all the zero product property is telling us. So this right here, from here to here, is your zero product property. So I was just getting this one started. There's no GCF. We're doing the puzzle again because there are 3 terms. So we would have negative 60 here, 7 here. What are we looking for there? 15, 12, 12 and 5? 12 and 5, negative on the 5. Okay, so we would have 3x squared plus 12x minus 5x minus 20 equals 0. I'm going to group these two together and these two together. So GCF here would be 3x, which leaves x plus 4. GCF here would be negative 5. The first one is negative, and that would leave x plus 4 again. So once again, these two match, so you're going to pull those out. X plus 4. And then what's left is 3x minus 5. And we set that equal to 0.
I have a question.
Okay, what's up?
So I did that, but I put, like, when I did 3x squared minus 5x.
Okay.
And then it was 12x minus 20, but like at the bottom I got like a different sets of numbers compared to yours.
Okay, so your order of those two terms shouldn't matter. If we group it correctly, so if I go through and do those two and do those two. So in this case, the GCF would be x, which would leave me 3x minus 5. Were you able to get that, Sarava?
Yeah.
Okay, and then over here, the GCF between those two would be 4, which would leave 3x minus 5. Yeah. So your matching would be the 3x minus 5. And so then what would be left over? You've got the 3x minus 5 you pull out. What would be left over is x plus 4. So you see how even though you flip-flopped them, you came up with the same two factors that I did. Did that make sense?
Yes.
Okay, so that's the kind of cool thing to me about factoring, and especially about the grouping. It really doesn't matter if you do it with the 12x first or the negative 5x first. You should get the same thing. Is that good? Okay, I'm going to go ahead and erase this one, just so I have room to do that one in a minute. Okay, so now we have our two factors. We set each factor equal to 0. So x plus 4 equals 0, 3x minus 5 equals 0. So x would equal negative 4 if I subtract my x, my negative 4 over, or my 4 over. Over here, I would subtract, add my 5 over, and then divide by my 3. So x would equal 5/3. All right, what questions do I have on that one? Okay. All right, so over here, concept is the same. My x squared is on the right side and it's positive on the right side, so I'm going to move all my stuff to the right. So I'm going to subtract this 28 over. So 0 would equal 2x squared plus x minus 28 now. Again, we're looking for factoring, and in factoring, I want to try to find my GCF first. There is not a GCF. There are 3 terms. So we're going to do the puzzle again. All right, so this time in the puzzle, a times c, 2 times negative 28 should be negative 56. And in the middle would be a 1. My b value would be 1. All right, so factors of 56, 1 needs to be negative, 1 needs to be positive, so I get a negative 56 in there. So I would say negative 7, positive 8 should get that one for us. All right, so now I'm coming over here. And I'm going to do the box on this one. Let's see, first term goes in the first box, 2x squared. The last term goes in the last box, negative 28. The two puzzle pieces we just found go in the other two boxes, negative 7, add an x to it, 8, add an x to it. All right, so now I'm going to be looking for the GCF of the row and the column. So across this row is 2x as my GCF. Across this row is negative 7. For this column is x. And for this column should be a 4. So my two factors would be 2x minus 7 and x plus 4. And that is still set equal to 0. And it really does not matter if you put that equal 0 in the front like I did here or in the back like we did over here with this one. The equals can go on either side. So then we separate and give each factor its own equal 0. So I'm going to write 2x minus 7 equals 0 and x plus 4 equals 0. So over here, in order to solve that for x, I would add my 7 over and divide by my 2. So x would equal 7 over 2. And over here, just subtract my 4 over to get negative 4. Questions on those two? Then what we have next, it says solve each equation by replacing f of x with 0, factoring, and then using the 0 product property. After solving, graph the quadratic, which you guys can do in Desmos, or if you have one of the school Chromebooks, you can actually put a TI calculator on there. If you don't already have your TI on your Chromebook, let me know and I can send you instructions to do that. It's super easy and it's really nice to have that onto your Chromebook just as a graphing calculator. Okay, so what I'm asking you guys to do is to replace the f of x with 0. Right, so now I have 0 equals x squared minus 2x. Once you do that, I want you to go ahead and solve. So you're going to factor, look for the GCF first, see what you have left over, set your factors equal to 0, and then after solving, I want you to graph the quadratics, and I want to see if you guys can figure out, like, what do you notice, and you can figure out which graph matches which equation and why. All right, so I figured this is probably going to take you guys about 10 minutes, maybe a little bit more. These go pretty quick because they're pretty small as far as the trinomials and binomials are concerned with factoring. So I'm going to give you guys about 10 minutes. I'd like for you guys, as best you can, try to solve each one of those equations and see if you can see some kind of relationship between the equation's solutions and what you're seeing on the graph. All right. This is what I was able to come up with for each one of these. So I have not matched them with the graphs yet. That's what I wanted us to talk about just a little bit. But those are the factors for each one of those polynomials. All right, so notice on this one, all it had was a GCF. On that first one, the blue one, all it had was the GCF. So I was just able to pull out the GCF, and then I set each one of these equal to 0. So that's how I came up with 0 and 2. The idea was the same down here. So the only difference between these two functions is the sign. All right, this was a positive x squared and a negative 2x. This was a negative x squared and a positive 2x. So if you factored out the negative with the GCF, that negative basically just divides itself out. So we end up with the same two solutions. What would the only difference between these two graphs be if this first one is a positive x squared and the second one was a negative x squared? Do you guys remember from your transformations with quadratics? What happens when we put a negative in front of the x squared like that? What does that do to the graph? Any of you guys remember that from our transformation stuff we'd worked on in chapter 3?
Is it a reflection?
Good. So yeah, that does make it a reflection. So this one's going to be a sad parabola. It's going to be reflected down, so it's not a frowny face. This one's going to be a happy parabola, opening up. So I have a few of those down here. Was anyone able to make a connection as to the solutions that we had going on down here and then the graphs that they matched? Did anybody come up with a match for any of those? Okay. Y'all haven't said anything that alarms me or makes me think that maybe we're not doing okay yet. So a quick review of simplifying radicals. This is what you guys were supposed to do with your Khan Academy assignment that you had due for today. So for simplifying a radical, I like the best way for me is to do a factor tree on it. And so if I do a factor tree, I'm looking at, I know 3 times 4 would give me 12. 3 is prime, so I would bring it straight down. The 4 would be 2 times 2. Okay, so basically the square root of 12 is the same thing as the square root of 3 times 2 times 2. And because I'm doing square roots, square would be 2. I'm looking for 2 of a kind. I'm looking for 2 of the same thing. So the way that I've explained this when I was teaching like younger grades, and it seems to stick pretty well, right? Right now, everybody's in the house playing inside together. And the only way that you're allowed to go outside of the house is if you have a buddy, if there's 2 of you to go out of the house. So this one, I have 2 2s. That means I can bring a 2 out of the house, out of the square root sign. Okay? The 3 does not have a buddy, so he has to stay in the house. So the square root of 12 simplifies down to 2 square root of 3. The 2 again had a buddy, so we could bring the 2 out. Basically 2 times 2 is 4, and the square root of 4 is 2. That's where we're getting that from. That's why that works. All right, so if we tried it with 20, 20 would be 2 times 5 times a lot of x's. Okay, again, all of those are in the house. They're all in the square root. And the only way they can come out of the square root is if they have a buddy. So we have a buddy of 2's here, so it can come out of the house. Those x's have a buddy, so an x can come out of the house. Those have a buddy, so another x can come out of the house. Buddy and buddy, so I can bring out 2 more x's out of the house. Now the only left in the house that does not have a buddy is the 5, so the 5 would stay in the house. Anything that's left in the house gets multiplied back together. Anything that's outside of the house gets multiplied together. So 2 times x times x times x times x, we would write as 2x to the 4th. And on the inside, all that was left was a 5. Are these sounding pretty familiar from what you guys worked on in Khan Academy, hopefully? Okay. So same concept with 54, I would break it down. I don't even have to use that, I don't guess. 54 would be, go ahead and do it, 9 times 6 or 6 times 9. And then you have all your x's, which I'll write down in just a minute. 6 is 3 times 2. 9 is 3 times 3. And then we have all of our x's. 3, 4, 5, 6, 7. 7 x's. All of those are in the house. They're in the square root symbol right now. Looking for a buddy. So let's see, I have 2 3's right there. So 3 can come out. There's x's. So an x can come out. There's another x. So another x can come out. And another x. So x can come out. All right, what's left in the house is a 3 times a 2 times an x. This little guy right over here that was by himself. All right, if we clean all of that up, 3 times x times x times x would be 3x cubed. 3 times 2 times x would be 6x. So that's what the square root of 54x to the 7th would simplify down to. Okay, again, the whole reason we're doing this is because we're about to get into square roots with another method of solving. So when there is only a squared variable, like an x squared, solving by square roots is a second method you can use. And again, you only want a squared variable in your equation. So you can't have an x squared and an x in your equation. Square roots will not work if that's the case. Okay, so I'm going to go through and work a few of these. And then we have that. And then talking about the graphing. Okay, sorry, just trying to remember what else was left on this one. All right, so example 4 through 6, solve the equations using square roots. So it's already kind of telling you there's only a squared variable in this problem, so you can use square roots. So for example, this one is t squared, so there's only a squared variable. So we get rid of the square by using its inverse, and the inverse of a square is a square root. So I'm going to take the square root on both sides of the equation. Okay. Over here, the square root and the square will cancel each other out, and I'm just left with t. Over here, I do need to put a plus minus in front of my square root of 400. And that's because both the positive and the negative root will make this equation true. That's how we're getting on the quadratic. That's how we're getting our two answers. And now we just need to simplify. What is the square root of 400? So that's what we just got through working on, was simplifying that down. So I know 400 could be 4 times 100. 4 would be 2 times 2. 100 would be 10 times 10, but I know 10 is 2 times 5, so I'm going to write 2 times 5 times 2 times 5. All of those are under the root. And again, looking for buddies. So there's 2's. There's another set of 2's, so I'm going to write down 2. I'm going to write down 2 again. And then there's also a 5, so I'm going to write down a 5. So in this case, because everything under the root got circled, everybody had a buddy, the root goes away. There is no more root, so I don't have to write the root down. So we would put t equals. We would still have our plus or minus, and then we're just going to clean this up. So plus or minus, 2 times 2 is 4, 4 times 5 is 20. So the answers to this the solutions to this equation would be positive 20 and negative 20. Okay, I'm going to take another second to take a breather. You guys doing okay? Did that one make sense all right? Okay. So what I'm going to do now, this one, if you'll notice, the t squared was already by itself on one side of the equation. The difference over here, there is a k, and eventually it would be squared if I was to multiply it all out. And I could do that. I could multiply it all out, but that's going to take a lot more time and make our equation a lot more difficult to solve. Instead, we're going to understand that this is my k squared, so this is my squared variable that I'm looking for. So I want to isolate my squared variable first. So when you're solving, you want to isolate the squared variable first. Okay, that's what's going to help you get going. And then once you isolate the squared variable, then you can use your square root. We want to get this itself. Isolate means get it on one side of the equation by itself. So what I want to do is actually get rid of that negative 19 over there. So we're going to add 19 to both sides to get rid of the 19 that's there. So that's going to give me 2k plus 3 squared equals 81 plus 19 would give me 100. Now that the square is by itself on one side of the equation, we can do the square root on both sides of the equation. So my square root and square cancel out over here, and I'm left with 2k plus 3 equals, we put plus or minus and the square root of 100. So I went and did the factor tree over here with 400 because I didn't know if you guys would be familiar with the square root of 400, which is 20. But hopefully we're familiar with the square root of 100. So the square root of 100 should be 10. So this would end up giving me plus or minus 10. So what I have now is 2k plus 3 equals positive 10, and 2k plus 3 equals negative 10. So what I need to do to finish solving the equation is I'm going to separate and make two equations. I'm going to say 2k plus 3, basically like what I just got through reading. 2k plus 3 equals positive 10, and 2k plus 3 equals negative 10. And then we can solve each equation separately. So over here, I would subtract my 3. So that would give me 2k equals 7. Divide both sides by 2, so k would equal 7 over 2. Same idea over here. I would subtract my 3, but this time it's going to be subtracted to a negative 10, so that would give me a negative 13. Divide both sides by 2, so k in this case would be a negative 13 over 2. All right, still feeling okay? Still making sense? All right, for the last one, I'm going to zoom in so I can get a little bit more space, a little more room. For the last equation, everybody tends to freak out. Oh my goodness, there's a fraction in there. Ah! Okay, so I'm going to show you guys right now, if you have fractions in your equation, how you can get rid of the fractions. It's not going to change your solution. It's just a way that helps you solve without having to manage the fraction. So if you'll notice, the denominator on both of those fractions is a 7. So what I can do, it's called clearing the fraction. So what we're going to do first is clear the fraction. And what that means is I'm going to take my entire equation, I'm going to multiply it by the denominator. If there's more than one denominator, you'll have to do a little bit more work, but this one doesn't. So, and I don't think on your homework it does either. I think they're all the same denominator. So I'm just going to show you this for right now. When it comes up again, we can kind of go from there. So now I'm going to take that 7, I'm going to distribute it to every term in my equation. So 7 times 1/7 p. What is 1/7 of 7? Well, that should just be a 1, so that gives me 1p. There's my equal sign. And now we're going to distribute the 7 to the 5/7 p. So 7 times 5/7 would just be 5. So now I have a 5p. Oh, this p was squared, and so is this p, 5p squared. And then we'll do 7 times, I don't want to get into my square, 7 times a negative 20, so that would be a negative 140. Alrighty. Now that we've cleared the fraction, we can go ahead and solve on this guy. So I don't want 2 squared variables, I just want 1 squared variable. So the first thing I need to do is actually combine some like terms here. So I'm going to go ahead and subtract my 5p on both sides. So if I subtract this 5p over here, 1p minus 5p would give me negative 4p. So negative 4p squared equals a negative 140. All right, my p squared is not by itself. Again, I want the squared variable or the squared term by itself. Notice that the negative 4 is not part of what is being squared. Only the p is being squared. If I want the negative 4 squared also, I would have to write it like this. Okay, this means negative 4 and p are both squared. This means only the p is being squared. So I'm going to divide both sides by 4 to get the p by itself, the p squared by itself. So p squared equals, let's see, what's 140 divided by 4? So 40 divided by 4 would be 10, 100 divided by 4 would be 25, so 35. Let's double check that. 140 divided by 4 35. All right. So negative 140 divided by negative 4 would be 35. Now that my p squared is isolated, I can take the square root. So over here, my square and square root cancel out, and I'm just left with the p equals, we have to put plus or minus in front of the square root. Anytime you take the square root of a variable, like I did over here, you have to put plus or minus in front of your answer. So plus or minus the square root of 35. And now I want to see if I can simplify that square root of 35. So I know factors of 35 would be 7 times 5. Well, 7 and 5 are both prime, and those are the only factors for 35 other than 1 and 35. So this square root does not simplify any further. So p equals plus or minus the square root of 35. That's my answer. That's as far as I can go. And it's okay for your answer to not be a nice pretty whole number or even a fraction like we have here. Some of your answers are going to be square root answers. So we're going to have to kind of start getting used to that because that's a quadratic thing. Okay, pausing again. Everyone doing okay? All right. Our last thing, we have this, and then I'm going to show you guys how to check your answers. So to compare the two equations, okay, compare the two that I gave you there. What difference do you notice? So the only difference that I see is that this one has a 2x and this one does not. Okay, because one has an x squared and an x, we would have to solve this one by factoring. Because there's an x squared and an x. This one over here, we can solve this one, a square root, because there's only an x squared. So there will be some problems on your homework where you'll have to determine which method you need to use. And this is really kind of what you need to take a look at as far as that's concerned. Is there an x and an x squared? If there is, you need to solve by factoring. If there's only an x squared, you can solve it by square roots. So the last thing to check your solutions, graph the quadratic. All right, the x-intercepts of the equation are the solutions. Now I also want to put down here roots or zeros. Okay, the x-intercepts of the equation are the solutions of the graph. You may also see it called roots or zeros. So if it asks you to find the zeros, it's asking you the same thing. All right, you need to find the solutions, which are the same thing as the x-intercepts. Now, I will tell you for the test, I would ask that you guys are not using the calculator. You're not going to be solving these by graphing. We are checking by We're checking by graphing only. Okay, so let's go through and take a few, because I think the last page was just some practice problems. Yeah. So let's go through and we're going to take a few on the on here, and I want to show you guys how to graph these in order to check them. So if you guys would, I'd like for you to go to desmos.com, desmos.com. If you haven't used Desmos before, it's awesome. All right, so Desmos is a free graphing calculator that's online based. So once you get here, you can just click on graphing calculator here. And then we're going to type in the equation. So you have to make sure your equation is equal to 0 because we're going to replace that 0 with a y. So I'm going to come over here and we'll start with our first one once we made it equal to 0. So we have 6x squared minus 5x plus 1. So that's what I'm going to type into Desmos. So y equals 6x, do shift and the number 6 to get your exponent. There's squared minus 5x plus 1, I think was that our equation? Minus 5x plus 1, okay. Again, we're using this to check our solutions. So what I can do is zoom in a little bit. Over here, we said our solutions were 1/2 and 1/3. So if I come over here and take a look on the graph, 0.3333 repeating is the same as 1/3. So there's one of my solutions as an x-intercept. 0.5 is the same as 1/2. So there's my other solution. Okay, did that make sense how to use the graph to help you check? So anytime you come up with a real funky solution, I definitely do the checks on those. So we could do the same thing with this one. Use your 0 equals, so this would become your y. So y equals 2x squared plus 9x minus 18. So let's check that one. 2x squared plus 9x minus 18. I think it was minus 18. Plus 9x minus 18. When we set our answers for this one, were 3/2 and -6. So I'm going to come back over here. All right, there's a solution, an x-intercept at -6. And there's a solution of 1.5, which is 3/2. Okay, so now you know how to be able to check all of your equations, right? So you can go through on the graph and have the graph help you check your answers. So for each problem that you do on your homework, I would recommend that you go ahead and put them into the graph and check them before you're actually submitting those or completing those as your final answer. What I am going to be looking for, however, is your work as well. So I do not want you guys just to go to the graph and try to find the x-intercepts and enter those as your solutions, because that's not showing the work on how we solved them by factoring or by the square roots. Okay, so graphing should only be to check, not to solve. So over here with this equation, are we going to solve by square roots or are we going to solve by factoring? So there's an x squared and an x. So that's what tells me I need to solve this one by factoring. This one over here, there's only an x and it would eventually be squared. So this one I would solve by square roots. Is that making sense how I'm making that decision? Scooting down. This one has an x squared and an x. So I'm going to solve by factoring. Again, this one has an x squared and an x. So I'm going to solve by factoring this one down here. All right. For some of you guys, this may look familiar. We called this factored form back in chapter 3. So basically, this is somebody has already taken the standard form of an equation and they've already factored it for you. So it's like jumping into the middle of the problem. So you don't even have to do any factoring. Just notice that you have two factors and you're going to set each factor equal to 0. And you're going to solve each factor for x. So in this case, x would equal 1. And over here, x would equal -4. Okay, we also called this intercept form. And the reason we called it intercept form, hopefully is making sense now. These are your x-intercepts, which we just figured out today are also the solutions to the equations. Alrighty. What questions do I have at this point?